All right, so we already started talking about graphing parabolas, and we've done a little bit with it over the past couple weeks. So yesterday we looked at graphing using opposite of b over 2a to find the x, and then plugging back in to find the y. That's all gravy. Like, there's multiple ways that you can do this, but the key thing is that you have to find the vertex first. So when it's in standard form, that's one option. And then our other option is to use vertex form. And this is what we've been practicing with a little bit on our bell work. So let's look at first let's look at standard form. There's only two things that you can even know just by looking at it. A, which is also in vertex form, tells us about the direction. And by direction, that's what I'm talking about, the happy versus sad graph. And then it also tells us about our width. Okay, so look back at yesterday's when we had 3 as the a term versus 1/2. Our parabola with 3 is much narrower versus our graph with a half, which makes sense if you think about it, because the 3 is telling us it grows 3 times faster than normal, whereas 1/2, it grows half as fast as normal. And normal, again, is talking about that parent function, the regular x squared function, no bells, no frills, no whistles, nothing's been added to it or taken away. So if we have our first function, f of x, so I'm looking at my a term. Okay, so -1. All right, just from it being in standard form, I can tell -1, awesome. I'm frowning. Poor thing. That is a really sad parabola. All right, and then it's 1, so it has a normal kind of width, but it's still going down. Also, don't forget about your c term. Your c term is your y-intercept. So we have a y-intercept of -8 here. So I'm going to wait to graph that because I need to make sure I don't have to count by 2's or anything like that. So we're going to convert to vertex form. So we need to factor out our a term so that we can get our vertex. And remember, when you're going to write your vertex, just drop your coordinates right underneath. H, your x value, is always opposite. Okay, that goes back to factoring because our solutions are always opposite of our factors. So h is your x value and k is your y. So if we go to do this, first thing, I do not have a perfect square trinomial because that 8 is not a perfect square. So I'm going to kick it over to the other side. And while I'm here, I'm going to go ahead and factor out the a term so that we can make a perfect square trinomial. Don't forget, you factored out -1 from both of the terms that are left over, the -x squared and the positive 2x. So when I factor out a -1, dividing by -1 leaves me with -2x. And now I'm going to fill in my blanks so that we can create our perfect square trinomial. So now we're going to do the jingle. So half it. So half that -2 gives me -1. Square it. But think about, what did we just add to the right side? So -1 squared is 1, but remember, it's inside parentheses. It's technically -1 times 1. So we actually added -1 to the right, so we need to add a -1 to the left to keep our equation balanced. So -1 plus 8 leaves us with 7 equals -1 times x, and now I'm just going to bring it down, that -1 and squared. Okay, so we have our a, we have our x minus h. Now let's just move this k term back over. So we have -1 times x minus 1 squared minus 7. and that is our f of x function, just written in vertex form versus standard form. So again, the whole point of that, so that we can easily find our vertex. So if I drop it down, remember x is always opposite, so my x value is actually 1, and my y value is -7. Oops. So 1, -7. Ooh, 1, 2, 3, 4, 5, 6, 7. However, we're frowning, so I'm going to have very little room here. So I'm going to go ahead and number by 2's. Even though I know it's going to end up in between, but that's all right. So if I'm going over 1, so 1, -7, 2, 4, 6, so I'm in the middle. And what cuts through our vertex? Go ahead and draw on your axis of symmetry. Oh no. Thank goodness for the undo button. And now let's use our trick. So a is -1. Now I'm using the trick, but also remember in standard form, C told us that -8 was our y-intercept. So 2, 4, 6, 8. And once I have that point, I can actually reflect it. So that was just another way to find that point. But even if we use the trick and we go over 1, if we plug it back in, 1 squared is 1 times -1, down 1. So go back to the vertex. Let's go ahead and find another point. So if we go over 2, remember I'm numbering by 2's, so that's why I'm only moving halfway. So 2 squared is 4. 4 times -1, -4. 1, 2, 3, 4. And I reflect over my axis of symmetry. And I got my beautiful little parabola. So we're getting the same results as yesterday. It's just a different method to get there. You have to know how to convert to vertex form on the EOC. However, if you're just asked to graph, you can do it either way that you want. So whichever method you like, yesterday's versus today's, just stick with that. That's fine with me as long as you're comfortable with it. Okay, so let's try the next one. If you want to try it on your own, just pause the video and then play it to check your work. So I'm going to start by, again, moving over that C term. Because even though 1 is a perfect square, 5 is not. So this is not a perfect square trinomial. And factor out my A term. So I'm keeping my 5. And I'm left with x squared. And 10x divided by 5 leaves us with 2x. And make sure you got a blank on both sides. So half it. All right, well, at least we've got nice numbers with and if they're asking you to purposely use vertex form, they're going to give you nicer numbers. So they're going to make sure to give you a B term that is divisible by 2. If not, that's something where you'd have to use quadratic formula. They won't ask you to do vertex form if it's not nice. All right, so half it. So I got 1 squared. Add it to the other side. So what am I adding to the other side? Hopefully you didn't just say 1, because remember, it's not just 1, it's 5 times 1. So we're actually adding 5 to the other side. So 5 minus 1 leaves me with 4, equal to 5. And we've got x, and I'm going to bring down my, this time we're positive, so plus 1 squared. So we've got our a, our x minus h squared. And now let's go ahead and move back the k. Again, if at any time this is too fast, just go ahead and pause the video and see if it makes more sense. If not, feel free to ask Miss Edie or Mrs. Kerstetter. They could probably help you out. All right, so there's our new f of x function. Wait, oh, it was a y. Just kidding, that was an equation, not a function. Okay, so let's graph. To me, that gets me there a little bit quicker than what we did yesterday, so I prefer this. But again, if it drives you nuts, then do the other way, it works too. So my x term, opposite, so -1, my y term, -4. So -1, -4, -1, -4, and I'm going to draw my axis of symmetry. And now I'm going to focus on my A. So when I'm looking at this, again, positive, so we have a nice happy graph. So when I go over 1, you can use the trick, or I'm plugging back into my A term. So my first term, so over 1, so since I'm moving over 1, 1 squared is 1 times 5, I go up 5. And I am to go over 2 times, that would be 2 squared, 4. 4 times 5 is 20. I definitely do not have 20 units to move up. So I'm just going to use that first point and try my best to make it look like a U and not a V. And there's your parabola. Notice how narrow that is, because that A term is 5, so it's moving 5 times as fast. That's quite a difference. So always kind of double check when you're done to make sure your graph makes sense. All right, now the one thing I told you guys that I want to go over, quadratics versus absolute value. Now notice, vertex form for a quadratic and vertex form for an absolute value. Exact same thing, except our quadratic is squared because it's a quadratic and absolute value. It's in absolute values. So it's works exactly the same way to find the vertex. The pattern, however, is going to be slightly different. So our HK is still our vertex. Yes, H is always going to be opposite, which is why it always says minus. But I'm going to show you the difference with the A term. So g of x, awesome. It's already in. Let's see if this will let me do this with the pen. Yay. So it's already in vertex form. Less work for us to do. So I just look at it and I know that my vertex, I'm going to write it above it so I have more room. So my vertex, my x, opposite of x gives me 3, and my y is 1. So 3, 1, I plot my vertex. I'm going to go ahead and draw in that axis of symmetry. And I look at my A term. So over 1, up 2. Over 1, up 2. Remember the pattern. If I were going to try and go over 2 to find another set, which you absolutely can, if I were to go over 2, I would do 2 squared because it's quadratic, which gives me 4. 4 times 2, so I'd actually go up 8. 2, 4, 6, 8. So we'd be way the heck up here. So that's why this is not a V, because it's growing in a quadratic manner. So we're squaring something every time we move over. Absolute value, on the other hand, I'm going to go ahead and set up my, axis. Let me see, actually first I'm going to cheat because I want to see how do I need to set this up. So find my vertex. So I got a -2 and bring it down, a -3. So -2, -3. So I don't need a whole lot of room. Oh, and my A term says it's going down. All right, so I want more room in the bottom half of my graph. Okay, so -2, -3. Beautiful. And now we look at our A. So, still has an axis of symmetry. So in some ways they are definitely similar. However, when this is an absolute value, what I want you to think about is an absolute value on a number line. Absolute value of 6. It's 6 units away. Absolute value of -6. 6 units away. So we're just left side